welcome back to our next video. We are going to now explore solving quadratic equations. And so what I need to tell you is that we've already started doing this. One of the ways that we've learned to solve quadratic equations already is by factoring and using the zero product property. But not all quadratic equations or functions can be solved by factoring because they're not all factorable. That doesn't mean that we can't solve them. So what we're going to do is we're going to learn over the next two videos how to solve them in two other ways. The first way is something called completing the square. And then the next one would be using the quadratic formula. Today we're going to focus on completing the square. Okay, and I want you to remember that essentially what we're doing when we're solving a quadratic is we are finding what are called the zeros of the function, if it's a function, or finding the x-intercepts or where it crosses the x-axis, okay? So let's just remember that the quadratic, the standard form or the general form of a quadratic function looks kind of like this, right? F of x equals ax squared plus bx plus c. And if we're solving a quadratic, we need to make sure that that quadratic is equal to 0 because we're finding the zeros of the function. One thing that we have to understand before we can use completing the square is something called the principle of square roots. And basically, the principle of square roots says that if you need to undo something that is squared, then you take the square root. And when you take the square root of something that's squared, you get two results. You get the positive of the square root, and you get the negative of the square root. Okay? So you get both the positive and the negative when you take the square root of both sides of a quadratic equation. Oftentimes, we will, rather than do it as two separate things, we will write it as one thing. So we'll start using the notation that looks kind of like this, right? Plus or minus. So in other words, the positive and the negative of some result, okay? So we might see it like this. X is equal to plus or minus the square root of k. So that's called the principle of square roots. You want to take a minute and just jot down in your own words what it means in the space that's provided there. But then we are going to move along, okay? And we are going to use the principle of square roots to start solving quadratics. And remember that the solutions, when we start square rooting things, could be a real number or it could be an imaginary number. So we need to keep that in mind as we work. Let's take a look at some examples of how the principle of square roots works. Let's look at example number 1. 4x squared plus 9 equals 0. So our job here is to solve for x. Solve for x. So what you might want to think about doing first is subtracting 9 from both sides of the equation. That's going to leave us with 4x squared equals negative 9. Dividing both sides by 4 leaves us x squared equals negative 9 fourths. Then this is where our principle of square roots comes in. We are going to square root both sides of this equation. Now, when we square root both sides of the equation, we get x equals, remember when we square root, we always get plus or minus. And now let's evaluate this piece, the square root of negative 9 fourths. Now, we're square rooting a negative number, so we know we're going to get an imaginary number as our solution. But what's the square root of 9 fourths? Well, square root the top, square root the bottom, and it leaves us with 3 halves. And because we know this is going to be an imaginary number, the result is 3 halves I. So the solution to 4x squared plus 9 equals 0 is x equals positive 3 halves I and negative 3 halves I. We actually get two imaginary solutions for this equation. Let's take a look at another one. All right. Now, our first instinct might be to start moving things to the other side of the equation. But I want us to stop for a second and just make an observation about what's on both sides of the equation right now. And my hope is that if you look at the left side of the equation, x squared plus 6x plus 9. You'll recognize that as a familiar type of trinomial. That is a PST. Do you remember PSTs, perfect square trinomials? When you factor a perfect square trinomial, you always get some kind of binomial squared, right? In this case, we get x plus 3, the quantity squared. So take a look at the result. We get the quantity x plus 3 squared equals 2. Now, we can use the principle of square roots and square root both sides. All right? When we square root both sides, when we square root x plus 3 squared, we get x plus 3. And when we square root the other side, we get plus or minus the square root of 2. Okay? So we have one last step to do. We need to isolate this x. So we're going to go ahead and subtract 3 from both sides. And what I like to do when I have a situation like this, remember, we cannot combine irrational numbers and rational numbers together. Instead, we're just going to rewrite it looking like this, right? X is equal to negative 3 plus or minus the square root of 2. I like to put the rational part first, okay? Rational part first, and then the irrational part. That's typically how you'll see these kind of expressions written, all right? Where you have a rational part and irrational part or term. So you should write it like this. So again, sometimes we have to factor in order to solve a quadratic just like this. When in doubt, factor it out. If it can be factored, try to factor it. All right, so this is using the principle of square roots. This is one way that we can solve a quadratic equation. We're going to put this to the test when we use our first technique, which is called completing the square. And this type of problem, the second example we did, becomes really, really, really important. Okay, let's take a look and see if we can make the connection about why that example became really important. So completing the square is a method for solving a quadratic equation. And the goal of using the completing the square method is to create a PST on one side of the equation. Because when we create a PST and we factor it, we get some kind of quantity squared, and therefore when we square root it, we're left with that quantity. Okay, so how do we make a PST? I've got a step-by-step approach here. I want us to go through and take a look at each of those steps through an example so you can see exactly what to do. Okay, so here's my quadratic equation. Notice that it's equal to 0. Okay, we like that. Step number 1, we're going to move the constant term to the other side of the equation. And we're going to make sure that a, the value of a, is not something other than 1. And if it is something other than 1, we need to divide all the terms by a. So in this case, we're going to move the constant 4 over to the other side. And we get x squared plus 6x equals negative 4. Okay? Now, a is equal to 1, so we don't need to do any division here. But in a few minutes, we're going to take a look at some examples where we don't have a equals 1. Now we're at the point where we are going to create the PST. Okay? Step number 2, create the PST. How do you create the PST? Well, what you're going to do is you're going to cut the b coefficient in half and then square it. So we're going to kind of undo what we do with that shortcut when we square a binomial. Remember how we double it and then we square the last term? So we're actually going to do kind of that in reverse, okay? So we're going to cut the b term in half and then we are going to square it. So for this problem, we're going to cut 6 in half, right? So we're going to do 6 divided by 2, and then we're going to square it. And the result should give us 9. We are going to add that 9 to both sides of the equation in order to keep that balance. So we get x squared plus 6x. Then I'm going to jump in here. I'm going to add 9 there, okay? And then I have negative 4, and I'm going to add 9 to this side as well. All right, so what I've done is I've created the PST. Here's my PST. Cut the b term in half, and then square it, and then add that to both sides. Now that should look fairly familiar, that PST. It's the same one, I believe, that we did up here, right? Is it? It is. So what do we get now in step number 3 when we factor the PST? Well, we get x plus 3 squared equals negative 4 plus 9 is 5. Negative 4 plus 9 is 5. So this is what it looks like. And we're going to just take a little side trip just for a second, because a trip down memory lane. Do you remember how when we talked about the expanded form of a parent function, especially the quadratic, it kind of looked like this. A times x minus h squared plus k. And then we talked about how when we transform quadratic functions, the h and the k are horizontal and vertical translations, right? And the coordinates of the vertex, so remember with a quadratic, it's kind of like that, the U shape, right? And then this is called the vertex. The coordinates of that vertex are at hk. So wherever h and k moved to the quadratic, that vertex point moved, and the coordinates of that vertex become hk. This we talked about when we did transformations. Well, this expanded form of the parent function is also known as the vertex form of a quadratic, because it allows us to figure out what the coordinates of the vertex are based upon the h and the k that are in that form. Well, if we head back over here, right, in step number 3, after we factored the PST, this is really, really, really close to the vertex form. For example, if we just moved the 5 to the other side, we get x plus 3 squared minus 5, right? And if you look closely, that looks an awful lot like that expanded vertex form of a quadratic. So we could, from this step right here, tell what the coordinates of the vertex are. The vertex would be at -3, -5, right? Remember how that h is backwards? Do you remember that? It's the opposite of what you think, right? Negative is right, positive is left. So if it's x plus 3, that means it's actually moved 3 units to the left. And x in minus 5 would mean 5 units down. So the vertex is now at -3, -5. Hey, that's really helpful for us to get an idea of what the quadratic function actually looks like when it's graphed. So to come full circle, the completing the square method is actually really good at helping us figure out where the vertex of the quadratic is without having to graph it, okay? So that's a little side note. We're actually going to come back here to step number 4. We haven't actually solved yet, right? So once we get to this point, I'll change it to green here. We're going to square root both sides, and we get x plus 3 is equal to, remember that, plus or minus the square root of 5. Plus or minus the square root of 5. Last thing we need to do, subtract 3 from both sides, and we get x is equal to -3 plus or minus the square root of 5. This tells us that our original quadratic equation has 2 irrational solutions, right? 2 irrational solutions. The first one is -3 plus the square root of 5, and the second one is -3 minus the square root of 5. Those are our 2 solutions to our quadratic. All right, so we're going to do a couple more of these, and then I'm going to give you some time to practice. We're going to do one where a is not equal to 0, too. That's the second one, so you get a sense of what to do there. There are going to have to be some fractions involved. But let's start at the first one, okay? X squared plus 5x minus 3 equals 0. First thing, add the constant to both sides. We get x squared plus 5x equals 3. The second thing we're going to do is we're going to take our b, cut it in half, and then square it. So half of 5 is 5 halves, right? 5 over 2. Square that, we get 25 fourths. That's the number we're going to add to both sides. X squared plus 5x plus 25 fourths equals 3 plus 25 fourths. Oh, those darn fractions. But I do have some good news, okay? Because we've created a PST, and it's a weird-looking PST, but because we cut b in half and squared it, we've ensured that we made a PST. So we know that it's going to be some binomial squared, and we know it's going to be x plus something squared. Well, I have good news for you, okay? Because the constant that's in that binomial is always going to be half of b. So it's always going to be the thing that we squared, right? In this case, it's going to be 5 halves. So x plus 5 halves, that quantity squared, is the binomial when we factor the PST. The only thing we have to do now is we need to simplify the other side. So 3, I always like to have common denominators here, is the same thing as 12 fourths. So 12 fourths plus 25 fourths is 37 fourths. Aha. All right. Square root both sides. Square root both sides. We get x plus 5 halves is equal to plus or minus, don't forget the plus or minus, and the square root of 37 fourths. Well, when you square root a fraction, you square root the top and square root the bottom. But 37 can't be simplified as a square root. So we're going to leave it as a square root of 37. But we can square root 4, and we can make it 2, right? So last thing I want to do is I want to subtract 5 halves minus 5 halves, and I get x equals negative 5 halves plus or minus the square root of 37 over 2. You can leave it like that, or because they have the same denominator, you can combine them together with something like this. Negative 5 plus or minus the square root of 37 all over 2. Either one of those would be an appropriate way to write the solution to this quadratic. It's all good. So fractions do introduce a little bit of complexity into the problem, but the arithmetic is all the same, okay? Let's look at one where a is not equal to 0. We're almost done here. I know I've been talking a while. We're going to start out the way we started before. We're going to move the constant to the other side, okay? So we get 3x squared plus 7x equals 2. The only problem is a is not equal to 1 in this case. And I don't know if you remember, but in step number 1, it said if a is not equal to 1, you need to divide every term by a. Okay, so divide every term by whatever a is. And since a is 3, every term gets divided by 3. That's going to leave us with x squared plus the fraction 7/3 x equals 2/3. Now we're ready to complete the square. So, do you remember how to do that? Take your b, 7/3, cut it in half. So how do you cut a fraction in half? Well, you just double the denominator. So 7/3 divided by 2 is 7/6. And 7/6 squared is 49/36. Okay, so we're going to add 49/36, so plus 49/36. We're going to add that, to both sides. Look at all those fractions. Aren't they beautiful? Do you remember from the previous problem, I said it's easy to figure out what that binomial is because all you have to do is cut that b in half. It's whatever half of that b is. That would be 7/6, right? So x plus 7/6 squared equals, and then when we add those two fractions together, let's see, 2/3. If we want to make it 36, we multiply by 12, multiply by 12. That's 24/36. So 24/36 plus 49/36 is 73/36. Okay. Square root both sides. X plus 7/6 equals plus or minus. 73 is another one of those numbers. You can't simplify if you take the square root. But the square root of 36 is 6. So the last that we want to do is pull them together. Remember, we got to isolate the x. So we got to move that 7/6 to the other side. We get negative 7/6 plus or minus the square root of 73 over 6. And we can leave it like that. Or we can combine them together and say negative 7 plus or minus the square root of 73 all over 6. Either one of those would be correct. Just get used to seeing them in both forms. Okay? So, there is one more. I'm going to stop talking. I'm going to give you a couple minutes to figure it out. Okay? And then I want you to close up this video, and I want you, when you think you got it, to go into the notes key in the Schoology folder and see how you did. There will also be some more practice problems in there along with the answer key, so you can get a better sense of how completing the square is going for you. If you have any problems, contact me and let me know. I'd be more than happy to help you. And if it's fraction work, I can help you with fractions. You just have to contact me and let me know. Good luck. Have fun with these. These are really satisfying once you figure them out, because it really feels like you're doing some complex algebra.